Hi class, it's your teacher, Mrs. Schwans, and this is number 2 and 5.2. The length of a professor's class has a continuous uniform distribution between 60 minutes and 90 minutes. If one such class is randomly selected, find the probability that the class length is less than 73.1 minutes. Now, in these problems, they're trying to teach you that the area, and we're going to see in general later on, the area under the curve, and the curve here is a straight line. Let me get a thicker line. A big key concept, though, is the area under the curve over the interval they're asking about is the probability that those interval, whatever's over the interval, will occur. So they shaded here, this is a visual image of so, and another important point in this section too is that, okay, we'll just go on with that, okay. So they've shown you a visual picture, of what the probability is. It is, and what they're asking for here. They said, find the probability the class length is less than 73 minutes. Well, the shortest class length possible is 60 minutes. So if it's less than 73, what they're talking about is what is the likelihood that the class is between 60, because it's going to be at least 60 minutes, between 60 and 73. That's what they're really asking for. And I know when you see this X less than 73, I think a lot of people think from 0 to 73, but no, that's not what's really meant here, because 0, they say this, that it's uniform distributed, meaning that it's equally likely to end at any time between 60 and 90 minutes. But that means outside of that interval, there's no probability at all of the class ending earlier than that. So that's why it's always good to draw your rectangle, and then that you're always, when they ask you for probability in this type of problem, you always know that they're always just asking you to find the area of a rectangle, within the bigger rectangle that you already have drawn over the entire interval from 60 to 90, whatever they tell you is the interval for the uniform distribution. Okay, so this is the region they're talking about. If they say the final probability of the class length is less than 73.1, that means, okay, what are if the class has to at least be 60 minutes, then this is it's got to be between 60 and 73. We need to add up, basically we have to add up the probability that it's 73 plus the probability that it's 72, which is between 71, or actually technically between 72 and 73 and all that we need to add. But like I said, they're trying to teach us here that the probability that it's going to be between 60 and 73 is simply the area under this curve. And one important thing is it is a rectangle. So it's just going to be a matter of calculating the height times by the base. And the height is a little bit hard to come by here. The height of this rectangle is just going to be it's going to be 1 over the base. It's just going to be the reciprocal of the base. So first, let's figure out the base. The base, you could count it, is 1, 2, 3, 4, 5. You could count it like that. But an even faster way to measure something on it is to take the large number where it stops and then, and subtract the smaller number here. So 73, that's a faster way than counting, right? 73 minus 60 tells us that, it tells us that the base here is 13. And it's fine with me. I can show you the complicated algebra to get there, or you could just have memorized for all of these problems. Oh no, I'm sorry. Base is 13, not 1 over 13. I'm doing already jumping ahead of myself. Okay, base is 13, then the height is just 1 over the base. Doesn't that make it easy? So it's just 1 over 13. So I plug in here. Oh, I'm so sorry. I'm so sorry. Okay, I'm thinking, okay. I have it all mixed up now. Hold on 1 second. Okay. And I'm glad I made a mistake because I'm sure that some of you might be making the same mistake. When you go to calculate the height of this rectangle, you need to calculate the height of the entire rectangle over the entire interval, because it is this height, which is actually the same as the other height, but all of the probability needs to be equally spread over that entire region. So we need to look at, when we calculate the height of the rectangle, of height of the blue rectangle and the height of the white rectangle, we need to, because the height of this white rectangle needs to be the white, and there's the rectangle over the entire interval needs to be an area of 1 whole. Okay, so that would mean that the height of this white rectangle, and that I have in black here, that I outlined in black, from 60 all the way to 90, the height of that rectangle needs to be 1 over the base of that wide rectangle. So the height here is actually 1 over the base of the entire rectangle that spans over the entire interval of interest, okay? So let me emphasize here. That it's the height, the base of the rectangle over the entire region. The base of the rectangle over the whole interval, not just the blue shaded interval. Okay, so that, when you look at we have to think about the base of that rectangle, it's 90 minus 60. Okay, so that would be 1 over 90 minus 60. So that's 1 over 30. So the height of this rectangle is 1 over 30. And then the base is different. Now we've calculated the height of the uniform distribution. Now we can focus on finding the area of this blue rectangle now the area of this blue rectangle is going to be the height, which is 1/30 times by the base of that blue rectangle, which is 73 minus 60, which is 13/30. Okay, I don't put that can't be reduced. So there we go. That is our answer. So just remember that, the probability that this event is going to happen is equal to the area under the curve, under the uniform distribution curve over that interval. And remember that they mean 73.1, but they mean only the numbers less than 73.1 that are in this interval. Okay. And usually drawing the picture can really help you. And all right. And when I say whole interval here, I mean that where they define like the front, it's continuous over this. There's a uniform continuous distribution over this entire interval. So that's the interval that I'm talking about, like the 60 to 90 is a whole interval that I mean there, okay? And this base in the second calculation here, that when you actually are going to find the probability, that's where you're going to use the base of the blue rectangle. Okay. All right. I hope that you guys, and this clarifies a lot for you guys, and let me know if you have any questions. Have a great day. Bye-bye.